Cool. So today we're going to build something. Let's look into the package JSON. First of all, I have a low-es ESM. ESM is ECMAScript module. That's right. And this library allows Node to use ECMAScript module. I'll show you in a bit. The prettier is just prettier. Okay. I'll show you how ESM works. I just discovered this today. It's very cool. So for example, if I export default free, and then if I do node-out ESM source index. No, sorry. And then now I can use import here. That's crazy. I mean, A from source index. And then A will be free. That's amazing. I discovered this today. Yeah, any question? No? Okay, sorry. I should not. Okay, so this is the package.json. Okay, let's go back to what I'm going to talk today. I've wasted like 10 minutes already. Okay, I have a lot to talk actually. So let's build something with reactive and watch. And we'll import it from Reactivity. So I have prepared ES5 and ES6, and today we're going to implement both. Okay, so let's imagine that this is the Vue reactivity, right? So we can create some break, and the break has some weight, and then we can create another break. To make it reactive, we can just grab it in reactive, and then we can just watch. Watch takes in a function, and we can just console log something. Break one weight. Break one dot weight. Something like that, and then copy that line for break 2. So whenever the weight of break 1 and 2 changes, this function will be called and the 2 lines will be logged. Okay, so if we go into ES5 and let's export the 2 function, const reactive. So reactive takes in an object and then it returns some object. I'll call it reactive object. Reactive object. And for the watch, it will take in some callback, and what it will do is it will first call the callback, but we will implement that later. In ES5, the reactivity is done with getters and setters. So let's look at getters and setters. So ES5 getters. That's the one. So what this function does is really simple. It takes in an object, takes in a key, and then you pass in an object descriptor. And in the object descriptor, you can describe what that property is. So there are properties like configurable, enumerable, value writable, get and set. And what we are looking at today is the get and set. So let's see how that works. So if we loop through the key and value of the object, and then if we just do objects.define property on the reactive object, and for the key and the descriptor would be some getter and setter. And for getter, the default behavior would be just object key. And then for setter, let's just console log something. I just want to show you guys how it works. Right. So if you run that, you see it logs getting, because in the index.js, we are getting the weight. It will go into this function. So that works. So now we want to set the value here. So say set interval. For every second, what we will do is change the weight to some random value, and then break 2 as well. Cool. If we run that again, we should see setting showing as well, because every second the value is being set. Okay, so this is basically how getters and setters work. So in order to make the value work, what we can do is we can have some internal value here, which will be the value. What we can do is just return the internal value, and then when we can set the internal value to whatever the new value is. The easiest way to make our watcher work is to, when the watcher comes in, we just keep track of all the watchers, and we'll push the callback into the watchers. And when the value is set, we just loop through the watchers. For each watcher, we just call the watcher. With that, we should be able to see, we'll see a log. The watcher will be called. Is it clear how this is happening to you guys? Is there any questions? Okay, cool. So if you notice, the first round, the break 2 has weight 0, right? So why is that? In our interval, we clearly set the weight, both weights to some random value, but the weight is 0 in the first round, so that doesn't look right. So if we put like this, you can see it clearly. So you can see every take is logging twice. The reason is because we're setting it twice, and here we're calling the watcher. So one simple fix for this is to, when we push the callback, we debounce it. So if we debounce the callback, when the setter is called, it wouldn't call the watcher directly, but queue it in the event. We just need to import the debounce from Lodash. With that, it should fix the problem with this. Yeah? Making sense? Okay, cool. Next, if we comment this out, and if we comment this out, now we're doing every interval, we're changing the weight of break 1, but because the watcher only depends on break 2, we'll expect this watcher not to be called, right? But in reality, it's still called, even though the weight of break 2 is not changed. So this tells us that we need to do some kind of dependency tracking, right? So in order to do that, we can somehow, if this watches is not all watches, but watches depending on this property, then the problem is solved. So the way that we can do that is that we can have a dependencies tracking. So okay, let me explain now. Sorry. For each watcher, they have their dependencies, right? So what we want to do is we want to see what are the dependencies. So for example, in here, when we call the callback, we want to know what are the dependencies of this callback, right? So how would we do that? So let's imagine we have a function called run and get dependencies, and it will give you some dependencies. And when we push our callback, we don't just push the function. We push an object of the callback and the dependencies. So let's try to implement that function. Run. It will take in the callback and it will do something. So now we have the dependency set. So we want to populate that dependency set. So first of all, let's make sure that the dependencies are cleared. And the next, obviously, we need to call the callback, because this callback will reach out to some reactive properties. And after calling this callback, this dependency set should be populated with the dependencies. What we'll do next is we'll get a copy of that dependency. Next, we can clear it again and then just return the dependencies. Right. So because this callback will somehow call some getters, right? So what we can do is we can add some dependencies. So what should we add? Maybe the key. But key might not be a good idea, because if you have two reactive with the same key, then the set has duplicating keys. We don't want that. So we need something that we can uniquely identify the key and the object itself. What we can put is a symbol. Symbol is great for this kind of stuff, because we can just create a new symbol here. We can label it with key. The label doesn't really do anything. And then what we can do is we can add the symbol. So with this, each property in the reactive will have its own symbol. By adding that symbol to the set, we know that the callback relies on that dependencies.
What's a symbol? How does that create like a unique identifier for that key then?
Good question. So symbol is a ESX new primitive value. So if we do node and then if we create a new symbol here, this is a new symbol, and a new symbol do not equals to the new symbol. So you can just do equality check on them, and as soon as they are the same reference, then they will be the same. The label doesn't do anything, but when you print it, it will show something like that. Okay, so now we have keep track of all our dependencies. Let's see if that works. So what we can do is we can set a timeout. After a second, we can just print the watches. And if we now run our script, it will get an error. That's obviously intentional, because it's an invalid or unexpected token on line 38. Oh, I forgot a comma, sorry. Let's do it again. Right, we got an error, that's fine, okay? Because we haven't implemented that. But we see here, okay, you can't see. So if you look at this watcher, now it becomes an array of one callback, and you can see the dependencies would be just one symbol, right? That is the weight that we are assessing. And if we uncomment this line, and if we go back to here and run it again, there will be two symbols now. So now we successfully keep track of the dependencies. Great. Okay, next, what we need to implement is watches depending on this property, because this is what the error is telling us. So let's say we have a function that get the watches. So get watches depending on the symbol. So if we have that function should return all the watches that depend. Yes, please.
I think we were doing for ES5, but symbol will be ES6. So why are we using symbol in this?
So why are we using?
Symbol in ES5.
That is true. That's a good question. Okay, so you don't need to use symbol, so you can just use nano ID or anything, just math random or anything. Just a unique identifier. I just want to be cool, you know. That's a good question. That's a really good question. I should not use symbol. That's right. That's right. But I've used it already, so let's ignore it. But think of this as some random hash string. Okay, that will work exactly the same. Okay, let's move on. So let's implement that function. That's such a good question. Oh my god. So it will take in the symbol and it will just return all the watches, filter out those watches where the dependencies. So remember the watches are callback and dependencies. The dependencies will where the dependencies has this symbol, right? Because dependencies are just symbol. So this will return all the watches that depends on this path, right? So with this, I think we're done. Let's see. Nope, of course. Because watcher is no longer a function, so we need to destruct it to get the callback, and we'll call the callback. Yes. Yeah, it's working. So to verify that it's working, we go back to index, and just now the situation was like this, right? So what it should happen is it should not keep on console logging break2's weight, because break2's weight never changes, so it should not be called. So if we go back here, okay, let's get rid of that console log as well. Let's get rid of this, go back here, and run this, and it doesn't do anything. That means our watcher dependency is working. Woo! Okay, next, ref. So next we need to make the ref working as well. Ref is very simple. Ref is just, it takes in the initial value, and then it will just return a, can you think how ref is implemented? Return an object, yes, return an object with value is the initial value. But this wouldn't be reactive. So how do we make it reactive? Yes, wrapping it in reactive, that's it. There we go, we have ref. Woo! So we can import ref here, and for example, if break2 is ref, then we can uncomment this. We'll do break2.value.weight, break2.value.weight, like this. If we run it, it should do the same thing. Yeah, it's working, but it's actually not. Why? If I comment out this line, and if I go back, it doesn't show new ones. Why? Why? Because in here, somewhere, we're assuming that all the values in the objects are just values. So that it's not reactive deeply. So we need to make it deep. So in order to make it deep, when we set the internal value to value, what we can do is we can check if the type of the value, if it's an object, then we can just call reactive, right? Otherwise, just value. Does it make sense? Yeah, so now that makes it reactive. So if we go back here and then do it again, hopefully, yeah! It's actually not working completely, because if we do something like this, break2.value equals to weight 30, that will replace the whole reactive object we just created. So this will not work. It will show 30 and then stop there, because that removes the reactivity from it. So what we can do is we can go back here. When you set a new value, check if the type of the new value is an object. And we want to make sure that the type of the internal value is also an object. If that's the case, then we can use object assign. Because if the internal value is already an object, that means it's already reactive. All we need to do is to assign the new values to the internal value. Otherwise, that means it's value, then we just assign it to the new one. Does it make sense? Yeah. And this should work, unless not. Okay, cool. Awesome, cool. We have implemented ref. So next, what else? What's the last one? Ref, reactive, watch, computed. Yes, computed. So let's implement computed. So let's say we have a computed function which we can calculate the total weight. It will be the break1 dot weight plus break2 dot value dot weight. Then let's create a new watcher that will console log the total weight. Total weight return also a ref, so I'll do dot value. So if I save this, and then let's move to implementing that. So any idea how we can implement computed? Yes, using the watch. And computed takes in the function that calculate the value, and it will return a ref. So let's create a reference, ref. So obviously the reference will be initiated with whatever is calculated, and then it will return a reference. And in order to make it reactive, we can just watch it. So we can assign the value of the reference to the new calculate. But because watcher calls the callback directly when we pass in here, so there's no need to do this. And there we go, there's our computed. And if we go back to our code, we should be able to see the total weight being updated, hopefully. Yeah.
Sure weight 1 is updated as well.
Yeah, that's a good idea, yes. I just thought the math would be easier for myself. Is it? Yeah. Yeah, okay. It's working. Great. Awesome. I'm almost to the end. Is there any questions so far? Yes.
So you've basically given us a demonstration of the new core of Vue without the fluff that you have to guard against all the other problems that might arise. You've just given us a demonstration of how the real core of it works, right?
Disclaimer, this is obviously completely overly simplified version of the Vue reactivity. The actual one is much more complicated, but this is just my imagined version of how Vue internal works. If you're interested, just go into Vue next and have a look at how reactive works. It's much more complicated than this.
With the ES6 in mind?
Oh yes, of course, ES6. I'll show you how ES6 works as well. Why do we need ES6? There's some caveats in ES5 reactivity. Does anyone know about the caveats in the current version of Vue? Add new properties, yes. So let's see what will happen if we add new properties. If we do break1.name equals to awesome break, and then add a new watcher, and then print out the break.name, break1's name. What we'll expect is, first the watcher will call console log, and we'll see break1's name is undefined because break1 is just having a weight property. And when you reassign the name, because the name property is not reactive, it will not be printed again. So if we go ahead and run it, you'll see undefined is being called, but there's no more about break1's name. So this is the caveat of ES5 reactivity. So what we're going to do now next is to make this caveat go away so that you can add properties, delete properties. So let's copy this code and paste it here. And the part that we need to reinvent is this part. So now currently it uses ES5 getters and setters. So any idea how Vue 3 will do this? It's proxy, yes. So proxy is a very powerful object. You can do all sorts of things with it. Basically, what it allows you to do is you can add trap to your object. So for example, this get trap. Let's hack this example. So if we do get return 4, and if we run this, you see the 2 console log will become 4. right? So we can sort of hijack the object and do whatever we like. So obviously, we will use the get trap and the set trap. So let's ignore this part of code for a bit. And the reactive object now will become a proxy. So the proxy target would be a copy of the object, and it will have the get set trap, right? And the get trap would be taking in the target and the key. And the setter will take in the target, key, and a new value. Very similar to the ES5 one. But what proxy enables us to do is, even we didn't do the define property on that key, we are still able to get the setting or getting through that trap. So that is what allows us to add new reactive property to objects. So the getter will do exactly what, not exactly, but similar to what we did before. We'll add to the dependency the symbol. So what should be the symbol? Symbol should be something related to the key. So let's say get symbol from key. So that function can just simply take in the key and it can just return some symbol. Because within this object, the key will not have duplication, so we can map key to symbol, new map. So if we add key to add key, and then we create a new symbol, symbol equals to the new symbol, and then we return the symbol. And then before doing that, we need to check if the key to symbol map already has the key. If so, just return key to symbol map get key. So that way, given the same key, we'll get the same symbol. Cool. And for the internal value would be just target key. The set trap would basically do similar thing here. Again, if the new value is object and the target key is an object, then just do object assign. Otherwise, we will assign target key to the new value, and then we will do the same thing for here. Except the symbol will be now generated from this, and then we'll call the callback, and then we need to return true for some reason, I don't really know, otherwise it will throw. But yeah, I think this is basically the proxy implementation, except the recursive part. So in this object, if there's a nested object, we can just call reactive on that nested object. So we can map values. So map values is a Lodash function, basically map each values into. So for example, if you have A1, B2, C3, the function will take in the 1, 2, 3 values and you can map them into new values. If it doesn't make sense, never mind. Basically, I'm mapping values. So the value will become from V to basically this. So let me repeat. The values in this object will be mapped to reactive value if the value is an object. No? Okay, explain again. So if I have A, B3, then the value would be B3. And we're mapping this to become reactive B3. Yeah? Cool. I think this will make our code work for additional properties. So if we change ES5 to ES6 and then run it, and then of course there will be errors, intentional errors, because it's not add, it's set. Go back here, run it. Of course, internal value, assign internal value. Okay, so it's not internal value, it's target key. Save, go back. And do you see what happened? The name is a new property and it's reactive. Okay, so this is all of my presentation today, and all the code is available here at YCMJason talks/blah blah 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 blah. And I've recorded this video and I'll post it on my YouTube channel as well. My YouTube channel is YCMJason. So I'll put it on and you can see it again. So yeah, thank you. Thank you.